So this is the ChatGPT. So I tried using this ChatGPT for solving the polar curves in calculus. So basically, this is my equations. Later, you will see in the screen. Okay. So basically, we have this curve r squared 8 cosine 2 theta, which is the lemniscate. So we are going to find the area inside this and outside the circle r equal to. And I'm asking the ChatGPT compute the area and then write the answers, and I would like to have the answer in radians, in fraction and radians. So the ChatGPT, oh, by the way, this is the ChatGPT 4. So the ChatGPT, it gave me the standard of the operation. So he gave me these steps. So first is finding the points of intersections, which is, I think, very clear. And we just need to equaling these two curves and find which theta that is going to be our intersections, which we are going to use that angle as our endpoints for the integrations. Okay, and then we integrate the area. Okay, this is very straightforward. And then subtract the areas that we are working. So for example, here is we want to make sure that the area was inside the lemniscate but outside the circle. Okay, like this. Okay, and then the ChatGPT will automatically calculate using Python. So it analyzes some codings, so writing some code, and then all give the solutions between the intersections. So this is going to be the intersections. So the result is it's giving the results, which is the 0.5 or equal to 2.6 radians. And then the next step is the ChatGPT will compute this points inside the formulation for the area. Okay, so so far so good, nothing's wrong. The lemniscate try. So first, the ChatGPT will compute the lemniscate using the theta, and then it's compute the subtractor area, which is the sector from the circle r equal to. And so far still okay, but I think there will be some mistakes which we are going to see. Okay, so it defined the intersection, is calculate, and so on and so forth. The area 1, area 2, I think still okay, although we're going to see whether this is true or not. And then it gave some area, and I think the problem probably is going to be in this area too. Okay, so it gives the result as in negative, so which means that somehow maybe there will be some miscalculations, because we are expecting the area to be positive, right? So it gave some conclusion in ChatGPT. It appears that there was misunderstanding in the calculation process, blah blah blah, and then the negative result indicate a mistake in the conceptual approach, which I agree that there will be. I think it is miscalculation from this area too. Okay, I think. Okay, and now he tried to correct the equations and tried to write a new code. So writing a new code, giving the correct value, and it gives, but I think since it is going to be using the same formulations, and the corrected curve, it goes to minus the A2. So it's still using the same A2, which I think this is the problem. Okay, this is the problem we're going to see. And the result's still the same. The result's the same. And ChatGPT also conclude that there was a mistake in the revised approach. And then given the unexpected result, the calculation was not corrected as intended. And blah, blah, blah. Let me correct my approach and ensure we accurately calculate the desired area. Okay, and then he tried to reevaluate all his steps. So still, it tries to make the curve corrections, and I think he tried to correct the sector area. So he tried to multiply half by 4, and then these theta differences. Okay. And then the desired area is the subtracted from the curve corrections and the sector area. I think the problem here is the theta he tried to use. Okay, and the problem in polar curves, basically, if you're not defining well for the integrands or the endpoints for your integrations, we need to make sure that the looping is only once. Okay? Sometimes for the polar, perhaps when we input the endpoints, the loops, maybe it traverses more than once. That will be a problem. So we need to make sure that it only traverses once. And to simplify the problems, we could try to make use of symmetry in the polar curves, okay? Because we can see some symmetry in this curve, which supposed to make our calculations easier. So still, it's negative. It's negative. So still, the problem, I think, maybe in theta. Okay, how he defined the theta, and I think there are many ways to improve how ChatGPT works. But let's see what does it says. And calculation have constantly resulted in an incorrect interpretation of the task at hand, and leading to negative area values which do not align with the expected outcome. Okay, so expected outcome should be area is supposed to be positive. Okay, so to blah blah blah. Okay, you could see how he makes some clarifications. And to clarify, the intent was to calculate the positive area contained within the polar curve and outside the circle, for which the direct subtraction was initially employed, which it is, I think, because I think the problem here, although the ChatGPT understand this is a polar problem, how he applied the polar problems within the calculus techniques, that is, I think, principally there's something wrong in that context. And then, given the complexity and of repeated oversight, the precise resolution requires evaluation of the integration limits, the correct application, blah 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 blah. And basically, he gave up. Okay, so ChatGPT gave up. Please let me know how I can assist you further. So I tried to help him. So let me help you out. You can use symmetry property from the polar curves. You can multiply 4 times the area from theta equals 0 to theta equal pi over 6. Okay. So I gave him some pointers that he can use 0 to pi over 6 and then multiply by 4. Okay, according to the symmetry. Okay, if you see the figure, you will see that it is practically important if we understand the use of the symmetry. It will simplify our calculation, but how to integrate that knowledge into the ChatGPT. That's I think what I can think of to improve this ChatGPT. Okay. So I think he need to improve how he read the context and then try to contextualize with how he analyzed through the Python. So yeah, I was thinking to help the learning process to like the machine learning within the algorithm in ChatGPT smarter. Okay, but let's maybe in another attempt we can try with different problems. So and then ChatGPT answering, thank you for pointing out the use of symmetry, which indeed simplifies, and then given the blah blah blah, and then calculate the area from 0 to pi over 6 for the angle, and multiply by 4 across the 4 quadrants. Okay, and then he can write the supposed to if you try to integrate manually, this is something that we expect to have. Okay, so if you are calculus students, this is something you are expecting to have in your solutions. Okay, so first you need to figure out getting this 0 and pi over 6 in the integrands, and then writing these subtractions. Okay, so basically this is subtractions for the lemniscate from 0 to pi over 6 minus the r squared for the circle r equal to. So this is 4. So this is basically a sector, right? A sector from 0 to pi over 6. Well, you can imagine a sector like a slice of pizza, okay, right? And then try to, I think from here, to make the code into the Python, it's much more easier because it is already defined, okay, as in the integrands. Okay, it is easier to write the code, and you see that I think it's okay. It's use this definition. Okay, just multiply, and then the functions minus the circle, lemniscate minus circle, and then multiply by 4. And we get the correct result, which is around this positive number here. Or in a more radians, we get minus pi over 3 pi plus 4 square root of 3 square units. Okay, then that's the, if you calculate through paper using manual solutions, this is something you are actually expecting. Or if you're trying using the calculators, that's the number you are looking for. So I think there are still many ways to improve, and yeah, hopefully we can see later. And basically you will see how I did this in manual paper maybe after this video. Okay, now I would like to go into the our problem in ChatGPT before. So I asked ChatGPT to find the area on this polar curves. Okay, so this is the area that I would like to be determined. This one and this one. Okay, so basically, what I found quite interesting is that I think because if you learn or if you study calculus and learn that when you have the parametric or polar curves, some common mistakes is that because it will have some loops for some curves, that for example here's the curves that are having a loop, right? So it's called the lemniscate. So basically, if we fail to determine the endpoints of the integrations, it means that we are going to visually make mistake. Okay, so if we want to find this a shaded area, okay, so what we want to find is we are going to define the shape first. So we need to define the polar shape, the polar curves. So if we imagine, so let me just um, write with the, let me choose the, say blue, light blue. Okay, or maybe just red. So the lemniscate at this point here, let me take this, and since this is already in proportions, so this will be the intersections, all these 4 points. And of course this is asymmetrical, which we are going to be use that property to help calculate the area. So let me take the, let's say this is the polar axis. Okay, now if we would like to, let's say, explore the area only for the lemniscate. Okay, lemniscate is the one that has this like an infinity symbol. Okay, so if we would like to know this area only from, let's say, from 0 to pi over 6, okay, for example, it means that we are going to take from this polar axis, we're going to move here and then stop here. So this is our area. Okay. So if I draw, then this will be the area. Okay. Okay, let's say this is the area 1. Okay. Now I will change the color, and then let's focus on the second polar, which is the r equal to, which is a circle with radius 2. So if we would like to know the area, or in this case the sector area, because this is a circle, like you slice a pizza out of this circle, right? Like a one layer of pizza. So this will be, so let me take this blue color, okay? And then we take this up until there. That will be O. That will be the area 2. So the shaded area, the gray area, if we just looking at this two area 1 and area 2, it means the gray area, suppose the gray area is the AG, let's say it's AG1. So AG1 will be A1 minus A2. Okay, and we have how many? We have 1, 2, 3, 4, and it is symmetrical. So we just need to find this one area and then multiply by 4. Okay, so it's quite simple if we looking at the paper, but I think since the ChatGPT mess up with this, this is supposed to be endpoints, and the points that he makes is only, I think this is only pi over 6 and 5 over 6 pi, okay, only the 30 degree and 150 degree. So he missed out the other two, right? And that's why I helped ChatGPT to clarify the equations, the area. So if this is the case, then the area will be 4 times that, right? Which is, this is from 0, from angle 0 or theta equals 0 to 30 degree or pi over 6. So this will be from 0 to pi over 6. And remember, the lemniscate is already on the square, okay? And so we don't need to square the equation. So we just need to write half and then 8 cosine 2 theta minus half, and then this is just 2 and then squared, okay? And I think this is precisely the build up for the integrals, right? And I think this is, I think, quite easy to solve. We can just take this, taking all the things here, right? So we have a 2 and then 8 So I think we can write 8 outside, and this will be 2. So this is 4, 4. So I think this will be, I think I will just write here a 2 cosine 2 theta, because it's supposed to be 16, right? I will just simplify it, and then this will be 4, and 2 is 8, so this will be 1, right? Okay. So 8, and this will be sine 2 theta, divided by 2, it will be 1. So this is the result, and 1 will be this theta. So we can plug in these informations, which we have 8, and the pi over 6, it will be what, pi over 3, right? Sine pi over 3 is half square root of 3. So this will be that and that, and we can cancel out this. This will be what, 4, and then this will be 4 over 3 pi, and that's what, how we get the results. Okay, so basically that's the answer, and yeah, that's it. So it's really interesting to see how the ChatGPT works and try to configure the Python code. He tried to analyze the questions, although I must admit the procedure, as in as we've observed so far, ChatGPT has a correct procedure, and all the formulations are all correct. But I think what he I think the only weaknesses is how he understand the context and then apply it in the Python code. That's I think the point that I think need to be improved. So context wise, the system understand, but when he applied in the code, I think that's a problem. Because he by default using Python, but if I try to maybe encourage the ChatGPT using in MATLAB, maybe have different results. But anyway, that's just to show you how the ChatGPT works, and it seems that there are still gap to be improved, and I hope you can take benefits from this video. Okay.